So here is the 17th question. It says that the height of a female university student is normally distributed with mean 1.74. So I'll start writing it like this. X is normally distributed with this 1.74 meter. That is the mean. And the standard deviation is 12.13. We were doing this in the previous group, and we were deceived by this unit here. You see here the unit is in meters, and here it has been given in centimeters. And thanks to, I think Iman Tusi told us that there is a problem with the units here. So we have to convert this into this meters here. So this would become 0.123 meters, okay? And since it's a standard deviation, so I need to put a square over here, because the parameters for your normal distribution, they are mean and the variance. We were given the SD, the standard deviation, so I have to put a square on it. Okay? Then it says a randomly selected female student is between 1.71. We have to find the probability that a randomly selected female student is between this and this. So we have to find the probability that a student is between 1.71 and 1.84. Okay, we have to find this probability. So that will be equal to, so this is always about standardizing your distribution here. So this would now be, I'll be writing it as Z is going to be between 1.71, sorry. This is 1.71 minus 1.74 is happening here over this 0.123. And this one is going to be 1.80 minus 1.74 over this 0.123. Because we're using this formula, Z is X minus mu over the standard deviation. Okay, so let's use the calculator next. So this is 1.71, 1.71 minus 1.74 divided by 0.123. So this gives me minus 0.2439 minus 0.2439, and this one is 1.8 minus 1.74 divided by 0.123, and I get this as 0.4878. Okay, so this is phi of 0.4878 minus phi of minus 0.2439. So we'll be using two rules here. One is that if you have to find probability between A and B, so that is going to be phi of B minus phi of A. And secondly, the phi of minus A is 1 minus phi of A. So I'll be doing with this minus here. So 1 minus phi of this makes this plus, and this is going to be phi of 0.4878 plus phi of 0.2439, and you have a minus 1. Imagine this has been written as minus into 1 minus phi of 0.2439. When I open the brackets, this becomes plus, and we have a minus 1 here. Okay, now it's the time to go to the table there and see what are these probabilities from the table. Okay, 0.4878, 0.4878. So this is 0.488. I think that's enough. 0.488. Okay, this is 0.6873. 0.6873 plus the next is 0.244, 0.24 and and this is for, this is 0.5963, 0.5963 minus 1. Remember your probability, the final answer should be between 0 and 1, okay? So this is 0.6873 plus 0.5963, and then there is a minus 1. So this is 0.2836, and correct to three significant figures is 0.284. It's 0.284. That is the probability. This is the answer to this part A. Okay. And let me write this answer here so that we can use this for the upcoming parts here. So this answer over here is 0.284, the answer to the part A. Now look at this part B. Try to respond to it. In the meanwhile, I'm going to clear this area. Yeah, is there anyone who would like to tell me that what is the answer to this part B now? Acha, if you compare this with the previous question, when I think there were 468 patients, Anna, there were 468 patients, and we found a particular probability. I think they were waiting less than 9 minutes, Anna. In the previous session, we have done this. So we multiplied that probability with this number to find the number of patients out of these who had to wait for less than 9 minutes. As in this B part, it says 3 randomly selected female students are all, you have to look at this all, they are all between this range. So if this event is going to be named as A, so this means this is A and A and A situation. So it's, first of all, its answer is clearly, you can simply say this is going to be 0.284 raised to power 3. And then to be more specific, as Sarah was suggesting us, this can also be modeled as a binomial distribution. Let me say that there is Y, which is binomially distributed, and N is 3, and the probability of success is 0.284. And we have to find the probability that they're all three of them, they have this height, okay? So this is the probability of success for those people. So this would be 3C3.284 raised to power 3, and then 1 minus this 0.284, that is the Q raised to power 0. So this is 1, this is 1. Eventually you get the same answer. This is 0.284 raised to power 3. And you can, I believe you can calculate it yourself. There is no need to use a calculator. So look at this Z part now. Now this is clearly, like, written in the form that is for a binomial distribution. It says exactly 15 out of 50. So this is something like 15C50 kind of a thing between this. So in the C part, I would say, okay, let's say we have used this Y. So let me say this, we have, there is M is binomially distributed with 50 as our N, and the probability of success is 0.284. And it says um, 15 out of 50. So we have to find the probability that M is equal to 15. So this would be 15C50, and this is 0.284 raised to power 15. 1 minus 0.284 is 0.716. Okay, this is 0.716 raised to power 35. So yes, beta.
सर 50C15 नहीं है
15.
50C15 NCR
हाँ
50 ऊपर नहीं है होता
what
तो आपने नीचे
this,
किया
yeah, yes, thank you, beta, thank you. I just forgot it. What am I writing here? This is 15. Thank you, beta. 50C15. Thank you, beta. So this happens when you are doing something after a long time. This is 15C15 exactly, because this is NCR. Yes. So 50C15, And like, this way you will be finding all of this. Okay. So this was the solution to this. Let me write this neatly so you can, yeah, this was in fact a blunder that I was doing here. So this has to be uh, 50C15. Okay, yeah. So let me, so this is 0.1186. So that is going to be 0.119, correct, to three significant. This is the probability for 15 people out of 50 to have their height within this range. Okay. Next, we have to go on to the question number 16.